All right, welcome back to our second lesson for chapter 6. In this lesson, there's 4 pages, but it's not a very long lesson, so don't worry. We're going to start off sort of introducing the unit circle. Some of you may have seen it before, but let's take a look at a circle, but we're going to start with a point. So let's say we have a point here. Okay, and this is a point xy, but the important thing is the distance from the origin to that point is exactly 1, which we call a unit. Okay, and that point would have a value x here and y here to represent it on our coordinate system. Now this is a right angle triangle, okay, and we could write it as some sort of angle right here, where this would be 0 and this would be 90. Sorry for the writing, I'm using a trackpad. Okay, and 180, and at the bottom 270, and all the way back to 0 again, which would be 360. Now what we could do is we can actually solve for sine theta. If you remember sine theta, your trig ratio, which you can use for any right angle triangle, is opposite over hypotenuse. Okay, and in this case, opposite is y, and hypotenuse is 1. So y divided by 1, which means the sine of theta is just y, because y divided by 1 is just y. Okay, and what we can do is we can do this for all angles for theta, for 1 degree, 2 degree, 3 degrees, all the way around. It's a terrible circle. I'm not going to try to draw a better one. All the way around a full circle. All right, and sorry, just trying to scroll the page down. Okay, that was tricky. But then if you go down and we try some numbers, now we're not going to do all 360 numbers. We're going to pick some special ones like 0, 30, 60, 90, 120, and just going to keep going up by 30 degrees, all the way around one full circle to 360. Now if you do that, you just plug it in your calculator. You type the sine of 0, you get 0. You type the sine of 30, you get 0.5. You type the sine of 60, you get root 3 over 2, but we'll just round that as a decimal to 0.87, and then 90 is 1, and then it sort of does this. You might be able to see the pattern there. Okay, so you notice that all the way up to 180, all the numbers are positive, and after 180, they're negative. You can write negative 0 if you like. Okay, let's look at the next page. Oh, I need to stop this. All right, so here's the next page. Now on this page, I've plotted them where our x-axis is all of our degrees for theta, and our y-axis is, well, our y values. And if we plot it, you get this sort of, and I mean, definitely do it yourself. You get this wave. Oh, that was terrible. You get this wave. Okay, and that's what a sine wave is. Now it's actually a sine function. Well, how do we know that? Because at any point you can do your vertical line test and see that the function only passes through one point in our vertical line test. So yes, a sine wave is a sine function. Now the domain, well, this can go forever actually. I've only done one full cycle here, but you can keep going all the way to the left and all the way to the right forever. So your domain is in the set of all real values. Okay, your range, however, notice that we only go as high as 1 and as low as -1. So your range is in between 1 and -1. So we write it, it's in the set of all real values. It's an element in the set of all real values, but it is between, or is greater than -1, greater or equal than, or greater than or equal to -1, and less than or equal to +1. So it's in between -1 and +1. All right, we go over to the next page. All right, so this page goes over a lot new terminology again. So we are learning a lot of new terminology at the beginning of this unit. Sine function, sinusoidal function. what is it? Equation of the axis. Okay, so this is an important one. So let's look at this sine graph. Now this one has a maximum of 1 and a minimum of -1. They won't always be that. We are going to play with it. We're going to stretch it and like move it around, like translate it. Okay, so it won't always be between 1 and -1. But there's always going to be a midpoint right here that is perfectly in between your maximum and your minimum. Okay, that midpoint is called the equation of the axis. Okay, and then there's also amplitude. Your amplitude can either be the distance between the equation of the axis and your maximum, or the distance between your equation of the axis and your minimum. The value will actually be identical, right? Since your equation of the axis is right in between your maximum and minimum, then the distance between that axis and your maximum is the same as the distance between the axis and the minimum. So for this example, our basic example of y equals sine x, okay, the period, or the length of one full cycle, goes from here, 0, up, down, and back to 360. So that distance there is 360 degrees. The maximum value is here at 1, and your minimum value is here at -1. And then the equation of the axis will always be y equals something. And in this case, this line always has the y value of 0. That middle line. So your equation of the axis is y equals 0. And your amplitude would be the distance between that equation and either your crest or your trough, your maxima or your minima. Okay, in this case, 1. So your amplitude is 1. All right. Let me go. Okay, our last example that we're going to do is on this page. It says, Sarah is sitting in an inner tube in a wave pool. The depth of the water below her in terms of time can be represented by the graph shown below. So here's the graph. Now notice this isn't between 0 and 1, right? It definitely looks like a sine function, but it's translated up. And we'll do more about translating sine functions in a later lesson in this chapter. But for now, let's just analyze this graph using the new terminology we learned. First, period. Okay, well, let's take a look. Period would be from any starting point until you repeat the cycle right here. Okay, and it looks like from 0 to 3, so 3 seconds. So your period is 3 seconds. Your maximum height is right up here at 2.4, and your minimum height is right down here at 1.6. Now the equation of the axis is directly in between them. If you can just look, you can see that. If you want to calculate, you can simply calculate the average between your maximum and minima. So you can do 2.4 plus 1.6 all divided by 2. Right, so if you did that, 2.4 plus 1.6 is 4, divided by 2, you get 2. So the equation of the axis is y equals 2. Now your amplitude, okay, you can go from here and go, okay, from 2 to 2.4. Or you can just subtract the numbers, so 2.4 minus 2. Okay, and this would be your amplitude. And that would be 0.4. You could also do 2.0 minus 1.6, but again, it's going to be the same, 0.4, and that's your amplitude. Okay, so that's it for this week. Make sure you've gone over and tried to do the Chapter 5 assignment on the Google form, and work on the problems to start off with all this new terminology for the first 2 lessons of Chapter 6. And next week I'll try to get in 3 lessons of Chapter 6. If there's any questions, put them on that Google sheet from our classroom. Have a good weekend.